Okay, we're going to take a look at factoring quadratic trinomials. I'm going to split this into two sections. I'm going to have 7-4A and B. So our first section, we're going to deal with looking at quadratic trinomials. Ax squared plus bx plus c. Notice that we added the coefficient to x squared, which is now all of a sudden we're calling these quadratic. Review. If you had had two binomials, you would have used the FOIL method and you would have gotten this quadratic trinomial. Your 3 times 2 would have equaled 6. 2 times 5 would have equaled 10. And then you would have had the sum of the products to get your B value, which is 19. So using FOIL, you could solve this binomial, but we are going to want to work backwards and start with the trinomial and create the binomials. Factors of A will be the first term, and factors of C will be the second term. Factors are two numbers multiplied together to equal a product. To factor ax squared plus bx plus c, we're going to look at the sum of the products of the outer and the inner products. I'm using colors so that you can see the first term inside the two binomials is a. The second term in the binomials multiplied together is c, and the sum of the outer and the inner products gives you b. Since you need to check all the factors of a and c, it would be very helpful to make a table. This next table that I'm going to show you, however, is rather scary. It's very long, it becomes complicated, and I've used small values, so you could only imagine how much more complicated this could get if you were using any larger values. So I want you to be careful. I want you to realize that it isn't going to always have to be this difficult. I'm going to give you a shortcut, but first I need you to see what happens if you do it the long way. This is your textbook method. You open up an Algebra 1 textbook and they are going to give you all these tables. They want you to list the factors of the first term, the factors of the last term. They want to see the factors. They want you to do all of this. I'm going to show you a shortcut, but first let's see what they did here. Factors of 2. I list my factors of 2. Factors of 12. Notice my factors of 12 are 1 and 12, 12 and 1, 2 and 6, 6 and 2. You could easily go on and on. Imagine if your number was 64. Your list would go for a very long time. I now take my products of my outside factors plus the products of my inside factors, add them together to get my B value. I am looking for an 11. It took me 1, 2, 3, 4, my 6th try before I found it. That's going to take a while. You can see it's a lot of work, and I don't always find everyone to want to do all of that work. But please take a moment, stop your video. If you're one of my students, go back and look at your printed slides and take a look at what's happening here. The product of the first term equals A, the product of the second term equals C, and the sum of the products equals B. Now the shortcut, which we call Daniel's method. Several years ago, I had a student named Daniel. So Daniel, if you're watching this video today, this is dedicated to you. Daniel's method. Daniel said he noticed a pattern that if he took A times C and then just looked for the factors of that value to equal B, he could create his binomial. So A is 2, B is 12, or C is 12, I'm sorry. A times C is 24. I need factors of 24 that will equal a positive 11. So I find 8 and 3. All right, I come back here. I repeat my first term, ax squared. I repeat c as my last term. In the middle, I list my factors of 24 that are going to equal 11, 8x and 3x. When I add them together, I get 11x. The problem, I have this binomial, but it's not cleaned up. I have a common factor inside each binomial, and I need to pull those out. The common factor here is 2x. 2x goes into 2x squared x times. 2x goes into 8x 4 times. Common factor, 3. 3 goes into 3x x times. 3 goes into 12 4 times. Notice what just happened. X plus 4 is a common binomial. I bring it down. 2x plus 3 becomes my second binomial. And now if I use the FOIL method on 2x plus 3 and x plus 4, I will get 2x squared plus 11x plus 12. No sign at all means plus. So that's why when you see this 3 right here in front of the parentheses, that became a plus 3. So I need you to pause. I need you to take a good look at it. I did 2 times 12 equals 24. A times C equals 24. Factor 1 plus factor 2 equals B. So the factors of 24 become my F1 and my F2. 8 and 3 equal 11. I plugged them in right here. So you could just as easily, have left it blank, brought down the 2x squared, brought down the 12, and then you needed to add in the 8x, the 3x, and you needed to pull out the common factors. What happens if my b is negative? What if b is negative? Well, again, you can list all the factors of A, the factors of C. Again, every factor is going to have a -1 and -8, -8, -1. Depends if it's in the inside, the outside. You can start doing all your multiplication. I believe at this point you're saying this is too much work. Let me see that Daniel's method again and see if it works this time. Pause the video if you'd like to take a much closer look at it, but I want to skip to Daniel's video. In Daniel's method, again, he tells you to take A times C. A times C is 40. Find 2 factors of 40. The factors of 40, when added together, equal -14. So I had A and C is 40. I know that B is -14, so I bring the -14 down, and I'm looking for 2 factors. It's -10 and -4. I come back. Set up your 2 parentheses. First term, A, 5x squared. Last term, your constant, plus 8. This is what you just filled in. The -10 and the -4. Yes, they have an x, because when added together, you have a coefficient. You have x as your variable. So these are your coefficients. -10 plus -4 is -14, variable x. Here's my problem. These have a common factor. 5x squared and -10x have 5x in common. I pull out the 5x. 5x goes into 5x squared, x times. 5x goes into -10x, -2 times. Common factor, -4. I take out -4, goes into -4x, x times. -4 goes into 8, -2 times. Notice I have x minus 2, x minus 2. That becomes one of my binomials. +5 and -4 becomes my second binomial. if I take these two binomials right here and I multiply them using FOIL, I will get 5x squared minus 14x plus 8. You need to try that. You need to use the FOIL method and make sure you go back to it. So let's try one. I know that I'm going to try to write on here at the same time as I'm talking to you. I like to start it by putting in my parentheses. I just put them in to start. And I know that my very first term here is going to be 6x squared. I know that my first term here, or I know that my last term, I'm sorry, but my last term is going to be plus 5. What I'm looking for is what goes here. What are my two factors that I'm missing right here? Daniel's method tells me that if I take 6 times 5 and I do 6 times 5, I get 30. I now need two factors of 30. I need two factors of 30 that are going to equal B. They're going to equal 17. So what are my two factors going to be that equal 17? Everything is positive. It seems pretty clear to me that I'm probably going to use a plus 15. Let me get rid of some of this space. And that, of course, has an x. And I'm going to use a 2x. And all of a sudden, I have my two binomials. However, they have common factors, don't they? They do. This one's going to be a little more complicated, but what I have here is what goes into 6x squared and 15x evenly. Seems to me that I'm going to have a 3x. If I have 3x, that's going to go in evenly to be a 2x plus 5. I get to my next one. I already have a 2x plus 5. So what's on the outside that's invisible? What's my invisible lovely letter for multiplication? 1. And I can repeat it. This is going to give me 3x plus 1. Oops, sorry, forgot my times 2x plus 5. And I have solved, and I now have my two binomials, and I have factored my quadratic trinomial by using Daniel's method. 2b, you see that b is negative here, so you need to do it with negative. I'm going to stop the film. You try b, and let me move on to my answers. Stop the film. Welcome back. And here are my two answers. Uh-oh. Let me see. What did I do wrong? 3x. Oh, 3x plus 1. Notice here, I did 3x plus 1, 2x plus 5. But when I got to my answers, I have them flipped, but they're still the same. It doesn't matter which binomial came first. That was determined on whether or not I did 15 and 1, or I'm sorry, 15 and 2, or 2 and 15. That's the only thing that made my difference. I still get the same values. So 2b, 3x minus 4 times 3x minus 1. I'm going to stop the tape here in the middle, and then I'll go on to 7-4b as my next video. Please go back and practice.